Have you ever tried sending crypto on Ethereum only to get hit with a $20 gas fee for a $5 transaction? That's the high price of congestion on the world's busiest blockchain. But what if we could dramatically speed up Ethereum and slash those fees, all without changing its core? That's precisely where layer 2 scaling comes in, and it's changing the game. You're watching Factsralogy, where curiosity meets reality. Just a quick reminder, this video is for educational purposes only and is not financial advice. So let's start with the core problem, Ethereum's congestion. Ethereum is incredibly powerful and secure, but it's also extremely crowded. The solution isn't to tear down and rebuild the entire highway. It's to build new, high-speed express lanes on top of it. That's what Layer 2s do for Ethereum. So what exactly is a Layer 2 or L2? A Layer 2 is a secondary framework or protocol built on top of the main Ethereum blockchain, which we call the Layer 1. It works by processing transactions off the main chain, bundling them together, and then sending a compressed summary of those transactions back to Ethereum for final settlement. Think of it like using a fast self-checkout kiosk at a crowded supermarket. You complete your transaction quickly off to the side, away from the main queues. Then only your final receipt is recorded by the store's main accounting system. This approach keeps all the security and decentralization of Ethereum while making it vastly faster and cheaper for everyday use. Now, not all Layer 2s are built the same. There are three main approaches to scaling Ethereum. First, we have rollups, which are the most popular solution today. They work by bundling or rolling up hundreds of individual transactions into a single transaction that gets posted to the main Ethereum chain. Within rollups, there are two key types. We have optimistic rollups like Arbitrum and Optimism. They operate on a trust but verify model, assuming all transactions in a batch are valid unless someone challenges them with a fraud proof. This makes them fast, cheap, and easier to implement. Then we have zk-Rollups, which stands for zero-knowledge rollups. These use advanced cryptography called zero-knowledge proofs to mathematically verify every single transaction batch. They are incredibly secure and lightning fast, but they're more complex to build. Second, we have sidechains. Think of this like keeping a private tab open between two people. You can make countless transactions back and forth off-chain, and only the final balance is settled on the main Ethereum blockchain when you decide to close the channel. This is perfect for things like micropayments in games or streaming services. Let's dive a bit deeper into the difference between optimistic and zk rollups, as they're really at the forefront of layer 2 innovation. Optimistic rollups are like trust first systems. They optimistically assume everything is correct to save time and resources. There's a challenge period where anyone can submit proof if they spot a fraudulent transaction. This makes them practical and widely used today. zk rollups, on the other hand, are math first. They don't assume. They prove. They use complex cryptographic proofs to guarantee that every batch of transactions is valid before it's even posted to Ethereum. While optimistic rollups are dominant right now, many believe zk rollups are the future, offering the ultimate combination of speed, security, and even privacy. These aren't just theoretical concepts. Layer 2s are already powering some of the biggest applications in crypto. And now even major players like Coinbase are getting in on the action with their own Layer 2 base, which is built using Optimism's technology and is bringing millions of new users into the Layer 2 ecosystem. So why does all of this matter so much? Simply put, Layer 2 scaling is what will make Web3 accessible and usable for everyone. It dramatically lowers transaction fees, making it affordable for people to actually use decentralized applications. It increases speed, providing the smooth user experience we've all come to expect from the modern internet. And most importantly, it does all of this while preserving the core tenets of Ethereum, decentralization, and security. Without Layer 2s, Ethereum would remain a powerful but niche technology, too expensive and slow for global adoption. With them, it becomes the foundational settlement layer for a new, scalable, and decentralized internet. The future of Ethereum isn't just one single blockchain. It's a vibrant and interconnected network of many layers working in harmony.